Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutewa Sos Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 8. It says a battery with unknown EMF and an internal resistance of 1 ohm is connected to 3 resistors, a light bulb, a high resistance voltmeter, a switch, and an ammeter of negligible resistance. As shown below, the resistance of the light bulb is 4 ohms and the resistance of the 3 resistors are 2R, R, and 6R respectively. So that means in that order. Right, so we are given our circuit here below, and then we know the first thing that we have to do is indicate which ones are in parallel and which ones are in series, right? So our current always flows from the positive terminal all the way back to the negative terminal. So this is our current flowing, but then as soon as it gets to this point, then we can see the current has more than one pathway to flow. So that means it will split. Some of the current will move through this branch here. So meaning this R1 and R2 have the same current, but then some of the current will split and go to this direction here. And then there we go. So meaning this ammeter here is only reading the current of the 6R resistor or resistor R3. So this is our current moving in that direction, and then at this point the current rejoins, and then now we have the full might of the current passing through the light bulb, which is has a resistance of 4 ohm. So this one is connected in series since they will have the total current. So this is in series, and here we have a parallel branch, right? So this is our parallel branch. Now, that's the first thing that you need to indicate if you want to successfully answer these questions. Then 8.1 says define the term EMF. So easy peasy, 2 marks there. We say EMF is the maximum energy provided by the battery per coulomb charge passing through it. Passing through it. Right, so for 2 marks, that's how you are supposed to define EMF according to your CAPS document. Right, and then we have 8.2. It says when switch S is closed, the current through the ammeter is 0.2 amperes and the potential difference across R1 is 6 volts. So R1, we are given that the voltage in here is 6 volts, right? And then this is a resistance of 2R. Now write down the value of V2. We know the relationship between resistance and the voltage has to be directly proportional. So if we are to check the ratio here, we have 2R, right? And then which simplifies obviously to 2 is to 1. So that is the ratio. The ratio is 2 is to 1. So if this here has a voltage of 6 volts, and then here we can see that R2 has only a resistance of R. That means according to this relationship, the smaller the resistance, the smaller the voltage, right? So what would be the resistance in here? What would be the voltage in here? This is X here. So this is just 2X is equals to 6 volts. And then if we divide by 2 here, our X is just going to be 3 volts, right? So that's how you were supposed to figure that one out. So this has twice the resistance. That means it has 6 volts. So the one that has half the resistance must have half the voltage, right? So 6 volts, and then here we have 3 volts. So for 1 mark, you only needed to write 3 volts, right? So this is based on our knowledge of the voltage and resistance relationship. Now 8.2.2 says the current through R2, right? So where is R2? We are now looking for the current here in R2, the same one. So, okay, remember we had that this is 3 volts, right? And then looking at this, we have our current here, which is 0.2 amperes. And this is on a parallel branch. Now, again, we know that we can apply our relationship of resistance and current in the parallel branch to say that we know that resistance is inversely proportional to current. Now, looking at this resistance here, if we can combine these two resistors here, let's combine these two resistors to form one big resistor because they're in series, but then they're within a parallel branch. Always remember, I made you note with all the questions we've been doing pertaining electricity that if you have resistors that are in series, but then they're within a parallel branch, you need to take them as one big resistor. Right, so the 2R and the R, when you take them together as one big resistor, they will end up being 3R, right? So they will have a resistance of 3R. And then we're going to compare that to the whole resistance of R3, which is 6R. Now we are given that the current in here is 0.2. Now, what would be the current in here? Now, based on this relationship, this means that the bigger the resistance, the lower the current. So if this is 6R, has a resistance of 6R, and it has 0.2 amperes of current, then this is half the resistance, meaning it must have twice the current to that. So if this is 0.2 amperes, this should be 0.4 amperes. So if you want to further simplify this, this is based on 3R to 6R. The ratio will be 1:2. But then this is supposed to be 0.2 amperes here. So if we want that, we can simply say the ratio is 2 for this one. So this is supposed to be 2/1 multiplied by 0.2. And then this will give us 0.4 amperes. So that's how you show the calculation, but this is a 1-mark question, so it is just supposed to be 0.4 amperes. Again, here we simply used the relationship. The relationship between resistance and current is inversely proportional, so bigger resistance, lower current. Lower resistance, bigger current. Right. Okay, now 8.3 says calculate the resistance now of R3. So now we want the value. We want the value of resistor R3. Okay, so in this case, this is what we are going to do. Remember, we took this one as one big resistor. So if we are taking this as 3R, we must add those two voltages there to form a voltage. So let me indicate this. So now, when we combine this two here and take it as one big resistor, the voltage is now 9 volts. But then remember that this is a parallel branch, and then there is one factor that we know about resistors that are connected in parallel, and it is the universal truth that if these resistors are connected in parallel, they must have the same voltage throughout. So if this is 9 volts combined, also the voltage of R3 must be 9 volts. Right. So now we have 9 volts, but then remember we have the current here. So in order to calculate the resistance for 3 marks, we already know the formula that we have to apply is R is equals to V over I. So let's indicate that it's R3. Then the voltage has to be 9 volts as well because of parallel resistors. So 9 divided by 0.2. And then when you punch that into your calculator, you get 45 ohms, right? So the resistance of R3 is 45 ohms, right? And then now, done with that 3 marks. So 8.4 says calculate the value of the EMF, right? So to calculate the value of the EMF, this is for 6 marks. We know that its EMF is equals to I, and then R external plus R internal. But then before we can get to that, obviously we must figure out what is our total current here and then what is our R external. Now, how can we get the total current? We know again that I total is equals to I parallel which is equals to I series. Remember, we have deduced that this is 0.2 amperes, and then we did calculate the current in here, which is 0.4 amperes, which will be the same as the current in here, 0.4 amperes. But then since these ones are in series, you don't add the current, because even if you were to combine them and they form one big resistor, they would still have the same current, 0.4 amperes. Because remember, in series, we say the current is the same throughout. So in order to get our total current, we would have to add these two values, the 0.4 amperes and the 0.2 amperes. Therefore, our total current would have to be 0.6 amperes. Right. So note that I did not add this because it's in series. The current is the same. So the same current that passes through this resistor R1 is the same current that passes through resistor R2. So you cannot treat them as two different currents. But then here, the current that passes through here is not the same current in here, which is why I indicated by different colors. So it's the color scheme strategy that I use to remember that. So 0.6 amperes, that's our total current. Now let's go and figure out what is the R external. We know that R external is composed of the R parallel plus the R series. Now since we have the value here, it's 45 ohms, right? We can be able to get the resistance in here by saying, remember the 6R, in other words, the 6R is representing 45 ohms, right? But then this one combined here, because we're going to take it as one big resistor, that means we are looking to say what is 3R representing if 6R is 45 ohms. So we're going to put X here. And then if we are to do the maths here, this is supposed to be X is equals to 3 times 45 over 6, right? And then, so I'm just going to deal away with the R there. And then X is equals to, when you punch that in your calculator, it gives you 22.5 ohms, right? So that means 3R here will represent 22.5 ohms, right? Now, why do I need all that? It's because now I'm going to calculate for R parallel, and then let me use the product over sum formula. I know some of you prefer the one that goes 1 over RP. That one you always need to remember that after you get your answer, you need to inverse it, which is why you don't see me applying it a lot. Okay, so we have our R1. Let's take it as the 22.5 that we just calculated. Then the R2, we are just going to take it as all of this, right? So R1, I'm taking it as these ones combined, and then R2, I'm taking it as that one. So don't be confused. Then multiplied by 45 over 22.5 plus 45, right? And then if you punch that into your calculator, you will get exactly 15 ohms. But then remember, we are supposed to get our R external. So this is 15 plus the resistance in series, it's only this 4 ohm here. So 15 plus 4, that's 19 ohms. But then to calculate the EMF, now we come back to the formula. EMF is equal to I, and then R external plus R internal. The current totally, we have deduced that it is 0.6, and then R external is 19, but then the internal resistance, it is shown here. Even here we are told an internal resistance of 1 ohm as indicated here. So that's 1. Now when you punch all that into your calculator, you get exactly 12 volts, right? So that's how you were supposed to calculate your EMF. So note again, it's a 6-mark question. So that means you couldn't just directly go to this one. You needed to first find what's missing. So we had to calculate, or we had to figure out what is our total current, and then we had to calculate our R external. Then that's when we can then use the formula EMF. So always note that with your marks. A 3-mark question is just a straightforward question, but then a 5, 6, 7-mark question means that you still need to get some other values before you can get to what you are actually trying to calculate. Then, okay, let's proceed. We have 8.5, it says in a separate circuit, a variable resistor is connected to a battery with an unknown potential difference as seen in the following diagram. The graph below shows the relationship between the power dissipated in the resistor and the resistance of the resistor. And then they say use the graph to calculate the potential difference across the resistor, 4 marks. So of all the questions that were in this exam paper, I found this to be a very interesting question. It's an interesting question. Then 8.5, obviously, if you are given a graph, the only way you can calculate is to use the gradient, right? So we have mentioned that a couple of times to say that if you are given the graph and then they ask you to calculate anything, then you need to make use of the gradient. So we know that the gradient can be calculated by saying change in y values over change in x values. Now our change in y values will represent the power, and then our change in x values represent a 1 over r, right? So allow me to just write it like this because we already understand that over is the same as divide. So that's P divided by 1 over r, right? 1 over r, because this, we are given the inverse of the resistance. Now, obviously, applying our maths, we know that the reciprocal of divide is multiply. So that's multiplied by r. Remember, if I change this to a multiply sign, then this becomes also the numerator must become denominator and denominator numerator. So r over 1 will give us r. So that means my gradient will be represented by power multiplied by the resistance. But then now I'm going to be smart about this, right? I know one formula for power. Remember, what am I trying to calculate? The potential difference, right? Now, for power, I have this formula VI, and then I also have V squared over R, and then I also have I squared R, right? So I'm looking for a formula that will allow me to calculate the voltage, right? And then we can all agree that it can be formula number 1 or formula number 2. But then remember, I do not have the current, so that's also another problem. I do not want to introduce a lot of variables that I do not know. So I'm going to choose a formula that will actually cancel out the resistance because, again, we do not have the resistance. So if I were to use this formula for power and then substitute here as V squared over R, this will multiply out with the r, which this and that will then cancel out, right? So we are just trying to be smart about this. It's manipulation. Then the r and the r will cancel out. Then we are left with v squared. In other words, our gradient will be representing the voltage or the potential difference squared, right? So in other words, our gradient is that. So now at this point, we want to then calculate our gradient. Right, so how can we calculate our gradient? We can take the last point and the first point. So first point and last point, usually that's the easiest to do. So the last point corresponds to the 1,000 there and the 10. And then obviously here we have 0 and 0. So that means for the gradient. Now you can pick any other points. If you feel you want to pick this one and that one also, it's fine. But then all of this must produce the same answer because the gradient is constant here. Then, okay, y2 minus y1 over x2 minus x1. Our gradient will be, so I'm using the 1,000. I'm using it with these points, so minus 0. And then I'm using the 10 minus 0, so which will give us 100. Right, so this is our gradient. But then note that I said that the gradient is the same as having v squared. So now you can allow me to say v squared is equals to 100 in other words. Because if this is equation 2, this is equation 1, they are both equal to m, so that means I can equate them. Now to find the potential difference, I need to square both sides. The v is now equals to 10 volts. That's how you were supposed to solve that question for 4 marks. So as I said, it was a very interesting question. You needed to manipulate a few things there in order to get to that point, right? So this might be the question that dealt with a lot of you. But then it's very important that you note with such questions, you need to actually manipulate it from the gradient and also pay attention to how your formulas are and how you can manipulate in order to reach to the desired value there. Okay, so and that's how you were supposed to tackle this question, all for a total of 17 marks. Very nice question. It was pretty fair. Nothing very much difficult except maybe for this question. So, but then with all that being said, guys, please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit the subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.